Hello, super cool, super awesome, super fantastic students. Welcome back to another fantastic set of episodes on economics. So we're going to start into our pieces of chapter 12 through 15. So this one's actually pretty neat because now we're going to start going into different types of firm structure. So we've been assuming perfect competition this entire time when we have so many buyers and sellers that none of them really control what a price can be. Well, what we're going to do is we're going to take it and we're going to transition it to, well, what happens if they can? What happens if there's a monopoly? What happens if there's an oligopoly with maybe 6 or 7 people who are in charge of a large portion of the market? How do we deal and rationalize with these situations, and how do we decide to produce under these sorts of situations? We also start talking about the shutdown point. When does it make sense to close down the ski lodge for summer? When does it make sense to close the pool for winter? You know, these are questions that different businesses have to deal with every single day, and we're going to start to rationalize and put them together. So let me go ahead and screen share so we can just jump right on into it. Ta-da! Pieces of chapters 12 through 15. If you were going to read any of these chapters, chapter 12 would probably be the most useful to you. That's the one that we're going to go most in depth into. 13, 14, 15, those will be more survey overviews of here's ideas of what the differences can be. Let's jump into it. So what would be the really cool, awesome things for you to know from this chapter that will be useful in your real life after this? Well, first, to be able to know what these different types of firm structures are. We hear about monopolies all the time in the news. We hear about monopolistic competition, but what does it really mean? Down to the core, what does it mean? One day you may own a business or you may work for a business and you have to figure out where you fit in the giant variety of business structures they are. Are you the only person who produces something? Are there so many other people producing this identical product that you can't tell them apart? Or are you somewhere in between? And then how do you make your output decisions? So from there, we need to explain how price and outputs are determined. Then we need to think about why firms leave the market. Why do they enter the market? Why do they do these sorts of things? And then we need to think about the efficient and inefficient aspects of each structure, because there's some good and bads to being the only person in the market, right? There's some good and bads to having so many people that you really have no control. There's some good and bads to being able to have some ability to manipulate your prices based upon little attributes that you have that aren't really different from everybody else, but it's a little different. So let's think about this. Let's start with chapter 12, which is perfect competition. So this is what we've been assuming the entire time so far, right? These are the markets in which you have many buyers and sellers, and these many firms sell an identical product to many buyers. So that means that they're not slightly different products, right? It's not that we have a gel pen versus a Sharpie pen versus a ballpoint pen. It's the idea of, like, let's say fruit, bananas. You go to the farmer's market and there are so many different stalls of bananas, and you can't really tell any of those bananas apart, right? They look kind of the same. They probably taste the same. They're all about the same size. So there's many people selling to many people who want to buy. And there are no restrictions on entry into these industries. So if it's perfect competition, you can just come and go. I can set up a banana stand and sell bananas today, or I can close up shop and say, you know what, I'm good. I'm going to go sit on the beach. Beach sounds nice. I'm going to go sit on the beach and just not sell bananas today. You can easily enter or exit the market because there's no restrictions in a perfectly competitive industry, right? In this case, established firms have no advantage over new ones. So if you have so many people selling bananas, the people who have been selling bananas the longest at the farmer's market really don't have that much of an advantage. They really don't have any advantage over the people who just started that day. Because someone who's coming to the market and has 100 stands to choose from, what are they going to do? They're going to go to the one that has the identical product for the cheapest. Doesn't matter how long you've been there. So we also assume in this that sellers and buyers are well informed about prices. They know about what prices these bananas are running, and they know how much they can probably get if they sell them. And they have a good understanding of the prices that are available for this one identical product in the market. In perfect competition, each firm is a price taker. Now, there's two different types of things. There's price takers and price makers, and we're going to talk about both. And they're actually both definitions that I believe are on your homework and on the test. So a price taker means that you have no control over the prices. If I'm selling bananas and I get to the market and bananas are selling for 65 cents that day, all right, that's what I'm selling them for. That's probably equal to what my marginal cost is because everybody just keeps bringing the price lower, right? What if I went to the market and I said, I'm going to sell bananas for $1? Okay, well then the person across from me, he'll say, well, they're doing it for $1. I'm gonna do it for 90 cents. And then the person down that way will say, 90 cents, I'll sell it for 75 cents. And then the next person will be like, no, it cost me 64.5 pennies. I'll sell it for 65. And then it just drives this price down, right? So then you have to kind of take whatever the market price is, because you're competing with all these different stands selling the exact same thing. So if it's 65 cents at every other stall in the market, you're going to have to be 65 cents too. So you're a price taker in this situation. A price taker is just a firm that cannot influence the price of a good or service. You don't really have the power to. So what do profits look like in this? Because why do you sell anything? Well, it's because you kind of hope to make a profit, right? You want revenues, that's the money coming in. And then when you have your revenues minus your costs, that remaining bit, the difference between your revenues and costs, that's your profit. And we like profit, right? And the goal of each firm is to maximize their economic profit. So this isn't necessarily the accounting profit, right? They don't want to make as much dollars as possible. This one also thinks about opportunity costs. What would be the best way that we can possibly use the things that we are using to create this revenue? So what we do is we look at total revenue, we minus total cost, and that money in minus the money that we had to pay and the costs and the opportunity costs that we had to put in. This difference, this right here, is our economic profit. Total profit is the opportunity cost of producing, right? This is what we call normal profit. So what is total revenue? Well, I'd actually ask you to, calculate total revenue a few times in between your homework and the test. It's just the price times the quantity. If I sell 100 bananas for 65 cents, then I have made $65 for my total revenue, right? That doesn't mean that that's my profit, because there's still a cost to grow all those bananas, right? But that total revenue, the money in, is just the total amount that I'm selling. In this case, it was the 100 bananas times the price. And in this case, that was 65 cents. So that's the total revenue. Marginal revenue is the change in the total revenue from a 1 unit increase in the quantity sold. What you'll notice is this is linear, right? Okay, I'm selling bananas, and I have sold my 4th banana for 65 cents. So I've increased my revenue by 65 cents. I go in and I sell my 12th banana for 65 cents. The marginal revenue, the extra bit of revenue I'm getting from that 12th banana, is that 65 cents. I go and I sell my 80th banana for 65 cents. My marginal revenue from that 80th banana is 65 cents. So the total revenue that we have goes up by 65 cents for every single banana, right? So it's very constant in these situations. So let's think about a couple interesting pieces here. Let's put together a lot of the different graphs that we've seen so far this semester. So in perfect competition, we can sell any quantity we kind of choose, right? At some sort of price. So we need to think about what the marginal revenue is. Oh, we went back to sweaters. Okay, let's talk about sweaters, because bananas are cool, but I have graphs for sweaters. So let's say that the marginal revenue I get for each sweater I sell is $25, right? So I go, I make these beautiful sweaters, I take them to market, but there's a lot of people selling sweaters. Like everybody has sweaters out. Okay. Well, the market price is $25. All the other stands are selling these identical sweaters for $25. I guess I have to too, which means my marginal revenue, the extra bit I get in revenue, so not necessarily profit, but in revenue for each additional sweater that I sell, is equal to that $25 price. How do we get to that? Well, it starts off with our supply and demand, right? There's going to be people who wish to purchase these sweaters, and there's going to be people who want to sell these sweaters. In a perfectly competitive market, we assume that the price and the quantity equal out to this middle part right here where they intersect. So at this point, we see that our intersection between supply and demand is at $25 for 9,000 sweaters. Okay, well, let's think about the total revenue version of that, right? If we know we have 9,000 sweaters, well, the 9,000 times 25, that's 225. How do we get there? Okay, let's think about it. That first sweater, we make $25. That second sweater, we make $25. So we have $50 in total. That third sweater, we make $25. So we have $75 in total. That fourth sweater, so on and so forth, where we just add 25 for each sweater. So eventually we have 9,000 sweaters for $225,000, right? Okay, well, that's pretty equal to where we saw on our supply and demand. Well, our marginal revenue is pretty constant, right? we know for this first sweater, we're making $25. And for this second sweater, we're making $25. And for this 10th sweater, we're making $25. And for this 20th sweater, we're making $25. So our marginal revenue curve, so notice we talked about marginal cost a lot. This one's marginal revenue. Our marginal revenue curve for a perfectly competitive market is flat. It's just this flat line equal to 25, which is the same price as the market. So in the perfectly competitive world, and we know it's perfectly competitive because we see a flat marginal revenue curve. I'll talk more about that later, but that should be the hint in your head of, this is perfect competition. So if our price is equal to our marginal revenue, this marginal revenue right here, we have the price that's equal to our supply equal demand. Marginal revenue equals marginal cost, and that equals price. That's simple. So also, how do we know that that's marginal cost? Because this is a perfectly competitive market, right? So if I could sell it for less, I would undercut the price. What is the minimum you're willing to accept for a good as a seller? It's what your marginal cost is, right? So our marginal cost in that case would be equal to our price, which is equal to our marginal revenue. That's just kind of cool. So the firm, you need to make a decision, right? A perfectly competitive firm's goal is to make the maximum amount of economic profit, given the constraints that you face, right? It's still the fact that if I'm bringing my sweaters to the market, everybody else has identical sweaters. So I still live in that world, and I have to make my decisions based upon that. So first, I need to decide a couple key points, right? One, I need to figure out how to produce at the minimum cost. I need to figure out how to lower my cost as much as possible, and how to produce there. Two, I need to think what quantity I want to produce. Do I want to produce 50 sweaters or 100 sweaters? How much do I think I'm really going to be able to sell in this market? And then three, I need to figure out whether to enter or exit. I want to go into the sweater business. I know it's perfectly competitive. Should I enter? I'm in the sweater business. It's perfectly competitive. Should I leave and do something else? These are different decisions that the firm is going to have to make. So let's start with the easiest one probably, and that's the output decision. So the output decision is fairly interesting, right? Because we need to think about our total costs and we need to think about our total revenue. Now, if you go all the way back to the beginning of chapter 11, we know that we have in a general set of equations, right? We have our fixed cost, which was the line that went straight across. We had our variable costs, our total variable cost, which looked like it kind of increased with a slope. And then the fixed cost plus that variable cost was the total cost. In this first blue line, I have our total cost. Notice if you go back to those earlier notes, that has a very similar shape to this. Okay, now let's think about total revenue. So it doesn't matter what my costs are. I'm only making so much per sweater, right? So that first sweater, I'm making 25. That second sweater, I'm making another 25, so it equals 50. That third sweater, I'm making another 25, so it's 75. That fourth sweater, I'm making 100. This total revenue goes up in a straight line. Well, notice that we have some parts where total cost is more than total revenue, and some parts where total revenue is more than total cost. I actually have it on this bottom one to make it seem a little bit easier, and that's the idea of economic profit and economic loss. So we are operating at a loss if the cost is more than the revenue, right? So in this bottom one, this line equal to 0, that's our break even. Everything below it means that we're at an economic loss. Everything above it means that we're at an economic profit. So let's keep going. Let's say that we have one sweater. Well, at one sweater, we see our cost is above our revenue if we go up from here. Well, if it costs me more money to make that first sweater than what I'm making on the first sweater, I'm operating at an economic loss there, right? That's no good. We're not happy with that. Okay, maybe we can keep going. Maybe we'll get to this point at 4 sweaters. Well, with 4 sweaters, I'm making $100, and it also cost me $100 to make 4 sweaters. At that point, I'm breaking even. Well, maybe I get more efficient. Let's look here at 9 sweaters. At 9 sweaters, if we go up, we see that total cost is less than total revenue. That means I'm making more money, more revenue than what it's costing me, the total cost amount, right? That means that I have an economic profit. That's this bubble right here. This is all the area of economic profit until we get to 12 sweaters, because remember, total cost keeps going up, right? So total cost will eventually be more than our total revenue again. And that's where we get back to loss. We want to operate here, right? We want as much of this economic profit as we can possibly get. So when we have our output decisions, there's a couple different things we need to think about, and that's how much can we make? So we have economic loss here, economic loss here, we have economic loss here, economic loss here, but we have this special place where total revenue is more than total cost. Well, let's find the place on this set of lines where the difference is as wide as possible. So right here, when we're just getting into total profit, we see that revenue is just slightly more than total cost. So that's not good. That's not a ton of profit. Let's go all the way up here. When we're almost at 12 sweaters, maybe we're at 11 sweaters, so we see that revenue is slightly above cost, but not as much as it can be. Maybe right here at 9 sweaters, if we look at this revenue line, which is at 225, and then we look at the total cost line, which is at 183, well, 225 minus 183, that equals 42, right? 42, that's maximizing our economic profit. It's where we have a point where we have as much revenue minus cost as possible, but where we have the biggest amount of potential economic profit. That's right here. So isn't that kind of neat? That's how we make the output decisions, is we have to have a really good understanding of our total costs and a really good understanding of our total revenue. And then we find out where the difference in between the total revenue and total cost is maximized. So then we have to think more about this output decision. How do we decide if we're going to have more or less? Well, let's say that maybe I'm right here, right? Maybe I'm at 8 sweaters. Well, let's see, at 8 sweaters, if I'm thinking about maybe my marginal cost and my marginal revenue, because notice that this ends up at the exact same spot, this exact same spot as right here, right? So let's say that I have 8 sweaters. Well, my marginal cost is a little bit lower than my marginal revenue. Well, that means that there's profit that I can make, right? If I have one more sweater, the revenue I'm going to get from that one more sweater is more than what it's going to cost me. So I'm going to want to do it, right? I would increase. So if my marginal revenue is more than my marginal cost, I would want to increase my amount of output. What if I'm over here at 10 sweaters? Well, at 10 sweaters, that's where the bell curve started going back down, right? Our marginal cost is above our marginal revenue. So if it costs me a little bit more to make that next sweater than the amount that I'm going to get for that next sweater, I'm not going to want to do that, right? So if my marginal cost is more than my marginal revenue, maybe I should actually produce a little less. Because if I produce a little less, I'm not going to lose money because it's costing me more than what I make. Until I get to this nice sweet spot right here, where marginal revenue equals marginal cost. If marginal revenue equals marginal cost, economic profit decreases if output changes in either direction, right? So if I add more sweaters, I'm going to lose profit. If I stop making as many sweaters, I'm going to lose profit. Right here, I can't move without losing economic profit. So that means right here is where it's maximized, right? Now we need to think about temporary shutdown decisions. Why do snow cones not sell well when it's negative 20 degrees? Why do ski slopes not stay open on 85-degree days in the mountains? Why do pools shut down when it's too cold for anyone to go swimming? Well, that's because these are different decisions that these businesses had to make. And they do that by looking at what their fixed cost is and what their variable cost is, and then making a decision based upon that. If the firm makes an economic loss, that doesn't necessarily mean game over, right? If you've ever had a business, you've had a bad day at that business. Everybody has, right? You're going to have a day where maybe you put more into it than what it was really worth. But does that mean you shut down forever? Not always. Sometimes you just have a bad day. So sometimes we need to think about this temporary shutdown decision, where we need to figure out if we need to exit the market or stay in the market. And if a firm decides to stay in the market, well, we'll talk about it a little bit. If they decide to stay in the market, you need to decide if you're going to produce something or if you're going to shut down. So ski lodges. I just like this as an example. Ski lodges don't, every time it hits about April, sell off their entire company and just sell the business and leave, right? They don't just decide to exit the market and just leave everything there to sell to someone else as they exit and decide not to be a ski lodge anymore. That's not how it works, right? They decide to stay in the market. There's still a ski lodge, even in July, right? So they might decide to stay in the market, but then they need to make a decision. Are they going to produce something or are they going to shut down? Well, that's one that's really interesting to think about. And that's going to depend on our fixed and variable cost. So if I'm a ski lodge, right, and it's getting to when it's kind of warm, so we don't really have many tourists, there's not a lot of money coming in, when do I decide to maybe just board it up and only pay my rent instead of paying workers? I just pay my rent and wait to open back up for a while. I'm not producing any ski lift rides. Or when do I decide to just shut down temporarily, right? Do I continue to run the ski slopes even though there's no snow? Do I continue to have people on staff to be able to make hot cocoa for everyone when it's 85 degrees out? Maybe not. Maybe I decide not to produce something and to instead temporarily shut down. So temporary shutdowns just mean, hey, I know that I have to pay my rent, so I'm going to pay my rent, but I'm just going to try to pay this fixed cost because the fixed cost is important. I got to pay that. But I'm going to try to minimize my variable cost in a time where I can't produce anything. During the summer, ski lodges can't produce cool skiing, right? They just can't do it. So they might in turn decide to minimize variable costs, send all the workers home so you don't have all that labor cost. So the only thing they have to worry about is rent. So they'll just pay the rent while not producing anything, right? This is a way to minimize loss because you're going to have losses during the summer, but is that loss only going to be your rent or is that loss going to be your rent and the cost of your workers? Well, it depends, right? So let's think about a loss comparison. Well, the firm's loss is kind of equal to the total fixed cost plus the total variable cost, right? Minus the total revenue. Let's hold on, I'm going to draw this out. All right, so we're at Dr. Plemmmons Ski Lodge Emporium. I'm just a person of many talents. So let's say we have some mountains. They generally have some snow on top. It's pretty cool. And here's the cool little ski lodge, right? And sometimes you have to decide, should this be open? Well, let's think about that. So what is our equation for economic loss? So economic loss is equal to our, and I like to think about it kind of like this, total fixed cost plus total variable cost minus total revenue. Okay, let's say that I decide to stay open, right? It's summer. I decide, you know what? I know it's summer. I know it's summer, but I'm going to stay open. So, well, what happens? Let's say that I'm going to have rent, which is a fixed cost of, let's say, $10,000. Okay. And if I decide to stay open, I have 2 workers, and together these 2 workers are going to cost me $40,000 to keep the place up and running. Okay. But it's summertime. So maybe during summertime, the amount of tickets that are sold are, I don't know, oops. Maybe we're going to sell, let's sell 25 tickets. It's not very popular during summer. And all these tickets are to take the ski lifts and stuff are going to cost $100. Okay. Well, question 1, what's our total revenue? So this total revenue piece right here. Well, we know that our total revenue is equal to our price times quantity, right? So our total revenue is going to be equal, if we decide to stay open, to $100 times 25, which is $2,500. Okay, so let's do the, here, purple, stay open. Well, in this case, so we know that we have the 2,500, green? No, let's just stay with purple. We have 2,500 for this TR part, right? Our total revenue part. All right, now let's think about the total fixed cost and the total variable cost. Well, we know that the rent is $10,000. So we got our $10,000. And if we decide to stay open, we're going to have $40,000 in labor cost. Okay, well then that means that we have 140,000 minus 25,000. This means that our economic loss is equal to 115,000. Whew, That's a lot of money that we're bleeding out of this business, right? Okay. Let's say instead we decide to make a different decision. Maybe we're going to stay a ski lodge, right? But we're going to temporarily shut down. Okay, well, what happens if we shut down? If we shut down temporarily, well, it's only temporary till the end of the season. So we're still going to have to pay that 10,000. Oh, I just realized, let's make both of these 100,000 because I had done my math wrong earlier. Okay, so let's say that is 100,000 for the rent, right? So this 100,000, cool. All right, that's our total fixed cost. We have to pay that no matter what. Then let's say that there's the variable costs, right? Well, if I'm shut down, I have no variable costs. So that's going to be equal to 0. If I'm temporarily shut down, I don't have 2 workers running the place. I don't have to pay that $40,000. Okay, but what that also means is that my total revenue will be 0. If I have no workers there and I'm selling no tickets, then I get 0 for my total revenue component. So my economic loss in this case is $100,000. If I were going to come up to you and say, hey, I'm either going to take $115,000 from you or $100,000 from you, what would you prefer? You'd probably prefer this 100,000, right? Well, the ski lodges think that way too. They can either stay open and not make enough money to cover the wage of their workers, because notice that's $40,000 in wages, but they're only making $2,500 in ticket sales. I did some math wrong here because I called this 25,000. Oh, okay, fine. Let's say it's like this. I'm sorry, my math is all over the place. But 25,000, right? So, well, if we're going to lose 115,000 in that case because we don't make enough to actually pay our workers, well, that's a problem. But then we have this case where maybe we only pay the rent and we send the workers home, but we don't sell any tickets either because we know that we're not going to make enough to be able to pay those workers. Maybe we'll just decide to shut down. So what does this necessarily look like on a graph? Well, it looks like this, right? So we know that we have our marginal revenue, maybe how much we can sell something for. We also have our average variable cost and our average total cost. And then we have our marginal cost check mark. We know that our marginal cost goes through the lowest point on average variable cost. In this case, it's our marginal revenue. Okay, and then we keep going up. Well, if we have this point right here, where our marginal cost is equal to our average variable cost, well, this is sort of a shutdown point, right? Because we're not necessarily making enough to pay for the entire total cost, both the rent and the workers. So we have to think about, are we going to make enough to be able to pay or employ these workers? So we have to take this loss comparison and look at the difference in between our total fixed cost and our total variable cost and our total revenue, and decide this relationship of if we're going to spend more in one situation than what we're going to make, right? So we have this idea of a shutdown point. A shutdown point is the price and quantity at which a business is indifferent between producing the profit maximizing quantity and shutting down. That's the idea of my shutdown point is right at the cool ski lodge is right when I get down to about the amount of customers where the money I'd make off those customers is exactly equal to the wages I'd have to pay the employees to keep the place open, which means there's no profit for me, right? I'm just making enough to pay those employees. Well, then I'm indifferent in between shutting down or not. Then I can just close up the door, because if I'm not making any profit, this is just completely equal. Well, then that's my shutdown point. I'm very indifferent at that point. This shutdown point is wherever the minimum average variable cost is, right? It's the same point at which the marginal cost curve crosses the average variable cost curve because remember, that happens at the very bottom, at the very minimum of the average variable cost. At the shutdown point, the firm is indifferent in between producing or shutting down, so they might decide to actually shut down. If you have less than that, then they're definitely going to decide to shut down. So let's think about it like this. Let's say that, and our marginal revenue can't be higher, it can be lower, but the important part is we need to know where variable cost equals marginal cost. But let's say we have it at a point where we're actually just making, so our marginal revenue, what we're getting for that next, in this case, sweater, is just exactly equal to my marginal cost, which being equal to my average variable cost. Well, what does that even mean, right? That means in the case of these $17 sweaters, or well, these sweaters that cost me $17 to make, and I'm selling them for $17, maybe the amount of money that I'm getting in, this marginal revenue, is just equal to what I have to pay my employees. Well, at that point, we know we have a loss, right? Because if we're making just enough to pay our employees, we're not putting anything towards the rent. So at that point, if I'm just making enough to pay my employees, I don't care if I shut down or not, because I'm still going to lose the rent money. So this is something that we have to think about in this output decision, right? What if the price was between 17 and 24? So we have this $17, right? But let's say maybe the price was somewhere a little closer to like $19. Well, at $19, we'd be making more than our average variable cost. We're still not making enough to pay for both the workers and the rent, but we're above our average variable cost. We're making enough to pay our workers, plus we're making a little bit more than that. It's not as much as the rent, because it's not as much as the difference in between these two lines. But we're making money to put towards the rent. And sometimes making as much as you can to put towards the rent is better than, you know, not making anything towards the rent at all. So this is something that we have to think about. In that decision, we might decide to stay open and keep producing and just produce at a loss, because at least we're making some money for the rent rather than having to pay the rent with no money coming in. So we need to think about the firm supply curve, right? Because in this perfectly competitive market, firm supply curves can kind of show what our profit maximizing output can be, because it's just a collection of what our willingness to accept is when it comes to prices for different output levels. So if we have a really good understanding of the demand in a system, and we have an understanding of the supply, then we can know what's happening to prices and quantity in these perfectly competitive markets. And because the firm produces the output at which the marginal cost equals the marginal revenue, because you always produce for MC equals MR, just that'll be relevant later, just trust me, always produce for MC equals MR. It always comes up on the test. There's like 4 questions on it. Just know, if you know that, it'll make your life so much easier, but you produce at the point where marginal cost equals marginal revenue. And this is because marginal revenue equals the price, and the firm supply curve is linked to the marginal cost curve in a way. So let's think about this. We have a couple different points, right? We have this shutdown point right here. We have our marginal revenue curve. We have our average variable cost curve, and we have our marginal cost. Okay, well, let's think about what happens at different price points. Well, we know the point where we kind of break even, where our shutdown point is right at the 7 sweaters, right? If we produce more, well, if we produce more, we would need to make more marginal revenue, right? Okay, so at this point, I'm indifferent in between shutting down. But if my marginal revenue goes up, like maybe we move up to marginal revenue 1 right here, and I'm making $25 a sweater. Well, if I'm making $25 a sweater, I'm making more than my average variable cost, right? So whether I'm operating at a loss or I'm operating at a profit, I'm still making more than my variable cost, which means I'm making the amount to pay my workers, and I'm getting some money towards rent. Might be all the rent, might be some of the rent, but I'm making some money towards rent, right? So I'm going to want to do that. So that means beyond this shutdown point, when we produce more than the shutdown point, the supply is going to go up. We'll need higher prices to keep supplying, but we're going to supply. But if we have prices lower than that, so it costs us, and at this shutdown point, at this absolute shutdown point, we're making $17 a sweater. If you pay me $16, that's I can't do that, right? I can't do that at all. So I might decide to not produce. Everything in between $0 and $17, the quantity produced might actually be 0. So the short run market supply curve may not necessarily be that straight S line that we've been seeing. It might be this. So what we see is that in between certain prices, so in between 0 to 17, where I come to my shutdown point where I'm indifferent because I'm making my wages for my employees, in between that point, I'm operating at so much of a loss that I cannot take it. So I will not even open my doors. I will shut down, right? So in between these two, I'm going to shut down. Everything above that, I'm going to produce, but I'm going to need more and more money to continue producing, right? So here we see the market supply curve for sweaters when there's 1,000 sweaters, we're not going to really have any. And when there's 10,000 sweaters, we're going to need a high price for that. The marginal revenue needs to be rather high, right? So we have this sort of short run equilibrium. This is what our supply and demand looks like in the short run. We say this is in the short run because we still have the idea of fixed costs, right? There are things that we can't necessarily change in the short run. I can't change what my rent is. I can't change everything else. I can't change the number of ovens that I have in a pizza parlor. So in the short run, our market supply and market demand sort of look like this. But over time, I can change some aspects of my business. I can come up with more cost-efficient ways to produce. I could change the way that I produce something. I could change the ingredients that I use. But for right now, this is where I am. And our short run equilibrium is this point right in the middle. For here, it's that we have $20 sweaters for 8,000 sweaters, right? So to maximize profit, it doesn't not necessarily mean that we have a positive economic profit. So economic profit is the profit that also includes this opportunity cost part, right? And we think about that. So sometimes it's better to lose a little bit of money than completely shut down, right? Maximum profit is not always a positive economic profit. Positive economic profit means things are going great and we have way more revenue coming in than the cost going out. But sometimes we're in that point where we're making enough to pay our employees and we can put some money towards the rent. We may not have all the rent money, but we're making some of the rent money, which means we're operating at a loss, but it's less of a loss than if we had just closed the doors, right? And we still had to pay the rent, but we had no money coming in. It's better to make some of the rent than none of the rent. So sometimes that's what happens. We maximize profit, and maximizing profit's not always the easy thing, right? To see if a firm is making a profit or incurring a loss, we need to confirm or compare this average total cost curve, right? If our profit maximizing output makes enough that it covers not only our variable costs, but also our fixed costs, and we make more than that average total cost line, if that marginal revenue is above that average total cost line at that amount, then at that point, we are seeing a positive economic profit. But we don't always have to have that, right? In the short run equilibrium, a firm might make an economic profit, we might break even, or we might even have a loss, because that happens in the short run, right? In the long run, here's actually the really funny part. In the long run, well, we always break even. We never really have extra bits of profit in a good way or a bad way, because in the long run, if there's profits to be made, more businesses can come in, right? And if people are losing money, some businesses can leave, until we get to this point where we get to about where the supply equals demand. In the long run, there's no real economic profits. And that's just a really interesting thing to think about, because if there's profits to be made, new businesses will enter. And if everybody's losing money, businesses will leave. It always ends up around that break-even point. So we have these entry and exit decisions. New firms are going to enter industries in which existing firms are making an economic profit, and firms are going to exit an industry in which they're making an economic loss. All right. So that's how we kind of come up to this right here. We have, and these are just, you know, our beautiful, wonderful pieces of our graph. We have our check mark marginal cost, because marginal cost originally goes down and then it goes up. And then we have to think about our marginal revenue. We know that this is perfectly competitive because this marginal revenue line is flat. Where marginal revenue equals marginal cost, this is where we want to produce, right? At this point, it'd be 8,000 sweaters for $20. What we see in this example is that the average total cost curve is equaled out to exactly right there. That's not always the case. Sometimes we're making less than the average total cost, but more than the average variable cost. Sometimes we're making less than the average variable cost, and we decide to completely leave the market, right? And then we also have our long run average cost. So our long run average cost, notice that this is much more flat. That's because we can adjust everything in the long run. We can change the number of plants, we can change the number of buildings, but notice that we still get to the same point. And the minimum long run average cost, the bottom of that line, is still at the same point where it intersects with marginal cost. At this point, marginal cost equals marginal revenue equals our long run average cost. It just basically means these are all equal to 1 point. And because there are no differences in the long run, this means that we have no economic profit in the long run. Why do you start a business? To make profit. And if you see a bunch of businesses are making profit, you're going to try to swoop in and make some profit, and you're going to try to leave before the losses happen. But overall in the market, some people come in, some people leave, and it equals out to about the fact that there's going to be a break even for that market. Because if there's profits to be made, new people come in. And if there's profits to be lost, people leave. Oh, okay, well, that's a lot of the information about what does it look like in a perfectly competitive market when we have our flat marginal revenue curve. Next time, what we're going to do is talk about monopolies, monopolistic competition, and oligopolies. So these are just different sort of firm structures where marginal revenue doesn't necessarily behave the same way. And it's actually super cool. So I hope you're excited about that. All righty, well, I will talk to you all soon. Have a fantastic day. Oops.